I suppose when we think of plants, several things come to mind. We could think of them as food, we can think of them as decoration, we could think of them as a natural world, we can think of them as great sinks for carbon dioxide, and we can think of them as a massive oxygen producer. But thinking of them as electrical generators is perhaps a little harder to imagine. However, turns out that's exactly what they are, and we can harness the energy directly from plants. Now that might seem a little ludicrous, but there are in fact three main ways to do this, and one way we've already covered quite a lot in detail, making bio-based solar cells and bio-based batteries. The basic idea is the conversion of light energy into electrical energy using photosynthesis is possible. Of course, in a sense, this is a solar cell, with the added advantage if it cleans itself, it repairs itself, and if it goes really, really well, it increases itself. So it's no real surprise that the next step in fuel cells is to use that process of photosynthesis. The photosynthesis allows the plant to grow, it gives out waste products, and it's actually the microorganisms at the roots of the plants that are responsible for the production of electricity in the same way as a microbial fuel cell. Now, as they produce the electrons and the electricity, of course, carbon dioxide is produced. But then the plants are using up the carbon dioxide, which makes the whole thing net neutral. But essentially, it is a microbial fuel cell, but using photosynthesis. It doesn't matter which plant is being used, it's essentially the same process, and walls of mosses have been built, and they've put together a table of how much moss would be needed to generate how much power, and small-scale devices have been built like a coffee table and a clock to demonstrate the principles. Of course, that's not strictly using the plant to generate electricity, it's actually using the interaction of the plant with the microbes in the soil, which cause ion movement, and that interaction between the plant and the soil is where the electricity is generated. However, a paper came out in 2022 where the plant itself was used to generate. The problem with the previous method was that microbes need constant feeding, but in this paper what they were trying to do was directly access photosynthesis. Now, photosynthesis is where sunlight falls on the leaves and it drives a flow of electrons from the water, resulting in the generation of oxygen and sugar, and that means that photosynthetic plant cells are constantly producing electricity that can be transported to power an external circuit, and that was the effort here. Now, earlier what they'd done was put copper and zinc electrodes into things like trees, and to be honest, that was nothing more than a glorified lemon battery. But here what they're doing is accessing the internal material of the cell directly and using it as an electrolyte, with the covering of the cell actually making a micro battery. Using a specimen of Corpusculara lehmanni, scientists were able to create living solar cells by using platinum and iron electrodes. The team designed the experiment so that the protons within the leaf's internal solution could combine to form hydrogen gas at the cathode, and this hydrogen could also be collected and used in other applications. Now, a single leaf was capable of producing voltages of 0.28 volts, and connected to a circuit, it generated 20 microamps per cubic centimetre of current. If exposed to light, the leaf is capable of continuously producing current, just like a true living photocell. Okay, the numbers are much lower than with, say, an alkaline battery, but of course what we're talking about here is a single leaf, and of course that can be connected in series or parallel. Finally, there is another source of power from plants, and that is transpiration. Transpiration is driven by evaporation from the leaves, and what happens is it causes water to be drawn up and through the plant, which carries ions with it. And this ion transport, or movement of ions across a surface, can generate electricity. Unlike previous methodologies, which really involved sticking the electrodes directly into the plant or the plant's roots, Transpiration can be extracted as a process, and an individual device can be made using the effect of transpiration, but not necessarily using the plant that it's linked with. And it turns out that when water is transpired through a structure, it'll generate a considerable amount. And this paper came out this month, about 2 weeks ago, where they detail a fabric method. It's essentially a piece of fabric with 2 carbon electrodes, and you wet the piece of fabric, and as the water moves across that piece of fabric, it generates electricity. And it is a considerable amount. They've constructed a tent out of this and managed to charge a mobile phone using a tent structure covered in transpiration elements. And of course, on the channel we've done different batteries in earlier videos using exactly the same effect, demonstrating how to make these kinds of devices. So these tiny power plants doing things like charging mobile phones certainly represent a whole new way of looking at power plants and how we're going to generate electricity for the things that we need. It's still ongoing, obviously, but there are huge leaps and bounds being made in these fields, and with luck we'll certainly see some more very interesting, more powerful devices coming out where we won't need to rely quite so heavily on traditional methods. Anyway, I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.